Welcome, y'all, back to some more geometry. Today we're talking about parts of similar triangles. So last section we did talk about similar triangles, and no, I think the last one was proportional parts. Yes, parallel lines, proportional parts, and then before that was similar triangles. Now we're looking about things within a triangle. So let's start out with this. There's going to be three things that we'll talk about. We're going to talk about altitudes, bisectors, and medians. Okay, those are important right there. So we'll start with this first postulate. There's no name for it, but it's saying that, hey, if two triangles are similar, so we know these triangles are similar for sure, then the corresponding altitudes are proportional as well as the corresponding sides. So what this is saying is that we're going to go ahead and it's telling you, hey, let's go ahead and set a proportion within the triangle. So if both of these triangles are similar, have an altitude drawn in them. An altitude is a segment that goes from the angle perpendicular to the opposite side. So it makes a right angle. It's saying that, hey, those two right there, the two inside parts of the triangle, are similar to each other. So when you're doing this proportion for these to figure one out, you can say, hey, altitude to altitude, and then side to side over here. So, right. So as we set this up, we say, hey, X is to Y as A is to B. So altitude is to altitude as side is to side. So for example, here I tell you these parts right here that X, A, and B are equal to this. We're looking for the value of Y. So let's go and substitute that in. So we'll do 16 over Y equals 20 over 15. What do you think we're going to do, y'all? Yeah, we're going to cross multiply. So 16 times 15, that gives me 2. So 20 times Y is 20Y. So 20Y equals 240. So then we're going to divide that by 20. Y equals what, y'all? 12. Exactly. So at all three of these we're about to do, it's always remember this: inside part to inside part, and then outside to outside. Next one right here. So again, you have two similar triangles, and this time you have a bisector. So a bisector, again, is a segment that cuts an angle into two equal parts. So even if the triangle is something like, let's go with, bam, bam, bam. If it cuts the angle half, even though this is slanted, as long as it's showing that it cut this in half, that's still considered a bisector, even though it's not going like straight up and down like on this one right here. But yes, a bisector. So if that's the case, then the bisectors are similar to each other, and the parts, the sides, are similar to each other. So if they even did this one over here, a T and then W, those would be similar to each other. Oh, I'll have a 2 here. So in this case, they're saying, hey, the bisectors are corresponding and similar to each other, and the sides are as well. So this time we're looking for Q. So as we set it up, we have Q is to the other bisector, which is 8. And that equals the side of this one. So remember, we're doing Q cubed over R. So then we're doing S over T. We got to make sure we do the same order in here. So Q is to R as S is to T. So just like before, we cross multiply. So 12 times Q is 12Q. 15 times 8 is 120. We divide by 12 on both sides to get Q by itself. We get Q equals 10, y'all. Q equals 10. Okay, so that's the other one you'll see. The third one you'll see is this one right here. So we're talking about a median. So a median is a segment that goes from an opposite angle to the opposite side where it cuts the side in half. Okay, so altitudes make right angles. Bisector cuts the angle in half. Medians cut the sides in half. So just like the other ones, here we're comparing, hey, proportional parts. So median is to median as side is to side. Okay, so as long as we know they got, now, even though it has 1, 1, and 1, 1, all 4 of these are not congruent. It's just saying these two congruent to each other and these two congruent to each other within the same triangle. So let's go ahead and set this up. So we're looking for X this time. So we'll say B, which is 13.5, is to the other median, 9, as X is to U. All right, so just like before, we cross multiply. 9 times x is 9x. 13.5 times 3 equals 40. That's a weird 4. My bad. Back. There we go. 40.5. And just like everything else, to solve for x, we'll divide both sides by 9. So divided by 9, you get x equals 4.5. There you go, y'all. That's the majority of today's stuff. Last little bit right here. So we're talking about the triangle angle bisector theorem. So it kind of is relating back to this in a way, has its own theorem, but it says that, hey, if your segment right here bisects the angle of the triangle, then it's dividing the triangles themselves into two congruent, two similar parts. But this whole triangle now, right here, is similar to this whole triangle right here by those parts. So not only did it divide the triangles, the opposite side, into two proportional parts, it also made two smaller proportional triangles within itself. So if I were going to set this up, I would say, hey, you could say A is to B as X is to Y, or you could say, hey, A and X are proportional to B and Y. Either way, you're multiplying A with Y and B with X. A with Y, B with X. Just, you can say, hey, this is to this as this is to this, or you say this over this equals this over this. It still gives you the same ratio and proportion in this case. In this case, yes. So that being said, we're going to do this one here. So we're going to kind of treat it like this right here. We're going to say, hey, say A is to B as X is to Y. Now here's our problem though. On this particular problem over here, we don't have a Y, but we can write something that represents this only right here. Ooh, wrong way. That represents this right here only. What can we do? So we do know the whole thing is 42. Ooh, sorry about that. The whole thing is 42. And then this side's over x. So let's say we had a number right here. Let's say this was 10. How will we get that? Well, we take the whole thing minus 10. Well, we still do the same thing. We'll just have a little expression. We're going to say for this whole thing, it will be 42, the whole thing, minus that. In this case, x. So that is what this represents now. So as we set it up, we'll say this to this side of this side, this side of this side. So we'll do 27 is to 36 as x is to 42 minus x. Right there. So we cross multiply, we get 36x equals 27 times 42 minus x. We distribute that in there, so we get 36x equals 27 times 42. Gives you 1,134 minus 27x. Change colors. So again, we got to get x by itself. So we're going to add 27 on both sides plus 27. What did we get, y'all? Yeah. I'm going to continue over here. 63x equals 1,134. How do we solve for x? Yes, we divide both sides by 63. 63 divided by 63. X equals 18. Now though, if x equals 18, what's the value of this other side over here? We'll just, replace this with 18. So we do 42 minus 18, 42 minus 18. Then our missing side is 24. All right, now I did this particular example because you'll have one just like that. Okay, if you know what the whole thing is and you have a variable like this to represent one side, then the other side will be the whole thing minus that side to get this right here. Okay, if you have any questions, y'all, let me know. But other than that, have a wonderful, wonderful day.